Hello, my friends. Welcome back to another Micromotor workshop. Today, I want to talk about batteries. Hobby King, Tenergy, Graphene batteries in particular, but also batteries and micro batteries in general. There are quite a few other things that I received over the week. If I have time at the end of this battery punch out, I might talk about a few things that I plan to assemble over the next couple of days and weeks. Oh, wow. I don't know how that happened, but you just witnessed a live battery explosion. Nee, ist schon explodiert. So, yeah, awesome live effect. Let me open the windows a little bit. Smells like burned out batteries in here. So, you see what happens when you punch out batteries too hard. So, this was one of the damaged packs, which I frequently um, test on my load tester here to um, test if they're still good. So this one wasn't. Hang on a sec, I'll get a fan to move the air in here a little bit. Yeah, so don't try this at home, kids. Punching out batteries can be dangerous. I never thought I'm so lucky that it happens right at the right time, but there you go. Quite stinky in here, so let me put the fan over here. So, yeah, sorry, I have to open the door, which is not very good in terms of the contrast lighting. I'm sorry for that. Comparison's the best start to a live feed ever. Yeah, actually, I like it. So it wasn't planned, but um, if I could have, I would have planned it like that. So that was one of my 480 milliamp my LiPo packs, and I was actually wondering when this would happen because they are not cased, and I crashed them a lot. So if you look at this, for example, it has quite a few dents still formed, and the pack just ignited because well, I don't know exactly why, but what I did was discharging it over that iCharger 406 Duo at 10 amps and then charging it again at 1 amp. So usually the damage is created by discharging it and then it surfaces when you charge it. So the pack was already sitting here for like maybe 10 minutes or so, and I planned to do another punch out with the battery to show you how they perform if they already suffered a little. Well, and that sometimes happens, not very often, and to varying degrees. So I just get this one in here to show you. This was kind of a, I would say, mild reaction, although it completely burned up the pack, created a lot of smoke, melted the whole plastic stuff around here, has some metal bits coming out of it which look like blobs of solder. And yeah, I've done this a few times in various constellations. The most reliable way to even do this to perfectly good batteries is just to overcharge them on a nickel cadmium, or nickel metal works too, but nickel cadmium is easier program. If you want to see that, I forgot what the video is called, but way back, around 2 years back, on my Vimeo and I think also on the YouTube channel, I've done this to smaller packs, and you can get them to ignite much more wildly. So this one wasn't even spewing flames, but if you do it right, you can get a meter-long flame out of these batteries. So yeah, be careful when doing that. But yeah, you know, it's I have a rubber mat under here, so I feel safe with doing it again. Yeah, but I got interrupted when talking about Complacent says he remembers that video, so if you don't mind, post a link to that so you can see how even half the size of these batteries can be quite spectacular. So, talking about batteries in general, there's mainly 3 factors which interest me in these batteries in terms of getting the maximum punch and the reasonable flight time out of our beloved microquartz, and that is voltage, current, and weight. So the one which is the least debatable is voltage. We all run on one cell lipos, so they have 3.7 volts nominal voltage, 4.2 maximum, and around 3.0 minimum voltage. That's what most people agree about. So if you buy a single cell LiPo which says 3.7 volts, that's usually what you get without much room for debate. Weight is already a little bit of an issue. Some people, some dealers, manufacturers probably don't care. I mean, it's not hard to measure the weight properly, but in most cases, the weights stated on the website are usually wrong. So I don't even know what they've stated for these, what I have here, 750 and 950 milliamp packs, but also don't care, just put them on the scale. So these are the 2 easy values, voltage and weight. And now the difficult one, the current. I think most of you know, but just to make a clean slate here, I'm going to talk about C rating and how it might be determined. So we want to know how much current can any of these packs produce without falling apart and going off in flames. Usually they don't state directly the current they can produce, but they state a C rating. And there seems to be a lot of confusion about C rating amongst manufacturers and amongst users. And yeah, I was a long time confused about that as well, until I have made up my own way of figuring out the C rate, which yeah, has a lot of factors built in, so that's why I assume the inaccuracy we see in C ratings being stated by the manufacturers comes out of A, different ways of measuring that C rate, and B, let's call it optimistic marketing. Both together means that C ratings on batteries are pretty worthless, but I still need them to compare batteries to figure out, without flying them and crashing them and losing my stuff, what is a usable battery. So per definition, C rating means how much current can I draw out of a battery in relation to its capacity. So for example, if this battery has 750 milliamp hours capacity, that means I can at 1C draw 750 milliamps for 1 hour. Well, that's determined by the actual capacity, but 1C means I can draw that capacity for, well, the related current to that capacity for 1 hour. Now this battery is labeled at 65C discharge. There's usually two C ratings. The upper one usually means even less than the lower one. So in this case, I assume it's only the lower one, the continuous, which is stated on the battery pack. That means I should be able to draw 65C continuous and probably double 130C in peak. Now again, the peak is not defined anywhere, and probably everyone defines its peak differently. So I'm only going to focus on the continuous discharge. Now what does it mean if we can discharge 65C? So I need a calculator for that. That is 0.75 multiplied by 65 gives me 48.75 amps. So I should be able continuously to pull 46.75 amp out of this battery until it's empty. And what you can also derive from that number is how long will it take for that battery to completely discharge. 1C means it takes 1 hour, 2C means it takes half an hour, 60C means it takes 1 minute, and well, 65C means it takes a little less than 1 minute. Hang on, mail time. Hello? Do you need to sign something? Sweet, thank you. Moderately heavy stuff from Shuangwang, mail from China. It means you can discharge the pack in less than a minute, continuous, and if it's peaking a little bit, even less. So yeah, just consider that. Is that even useful? Do you want to have a pack which discharges in 1 minute? Well, theoretically, people say it makes sense to have a pack which is able to discharge in 1 minute, because then it will not sag in voltage if you discharge it slower. But yeah, in theory, we should be able to discharge, or say, according to the label theory, we should be able to discharge this pack within 1 minute. Now, what does it mean we can discharge the pack in 1 minute? So there's no real definition of that, so I'll start from the most possible conservative definition and then work my way down to a realistic one, which I'm going to apply to my tests. So the most conservative assumption, what manufacturers mean by I can safely discharge this pack with almost 50 amps in less than a minute means it does not disintegrate and burst up in flames while I'm doing it. So as you've seen, it's very possible for that to quickly happen. So I don't want to push it as hard that it goes up in flames, but ideally I still want to be able to use them afterwards. And also I want to apply a current which is somewhat realistic in relation to the actual target application, which is running this thing on a small micro quad with 4 motors pulling around 2 to 3 amp each. So I want to walk you through the values that I'm putting into this discharger in this case in order to test the batteries. So before I get into that, I'll read a little bit of the chat room and see what's going on here. If my fundamental rant / explanation about C ratings leaves any questions. I see some burned up batteries already here. Mr. E thinks that was worth the entry fee. Time for the fireworks. Yes, I let the smoke out, Mr. Master RC student. LiPo going thermonuclear. Ben's new opening sequence. Yeah, I should maybe go back after the video is uploaded and damn, I didn't hit record. You know, I can in my Wirecast application. I could have recorded that in a little bit better quality, but yeah, it's okay. Yeah, internal short, probably. So, you know, there's a layer of insulation in between the two parts of the battery, and that's getting weaker every time you torture it, either electrically or mechanically, and at some stage it's too weak to withstand the tension, the voltage, and gives in, and then yeah, the electrons equal out and produce heat along the way. That's, by the way, another good hint that you should store your batteries at storage voltage. A battery at 3.8 volts ignites a lot less wildly than a battery pack at 4.2 volts. So Pedro posts some pictures of burned up, I think it's a 750 milliamp nanotech pack. Science experience from last year. Complacent posts a picture of picture-in-picture chat and video watching on his phone. Well, that's pretty impressive. I need 2 computers to even do this. Scott is just so technologically superior. Yeah, he could teach us a few things about how to run Android, I think. Technology. Pedro is grabbing a screenshot of Ben smoking that lipo. Yeah, please post a picture and a gif of that. Yeah. I do a rap afterwards. Ding dong, sweet gears here in theory. Yeah. So, quite an arc of suspense. Starting with a boom, too many details. Time for some real numbers. Yeah, don't worry, they will come soon. We're gonna see smoke. Maybe. So we'll find out. So I have another pretty well dented battery, which I'm using for almost 6 months now. So I'm gonna punch that through the discharger to show you how, yeah, kind of a little bit tired battery performs. And then while I'm doing this, I'm continuing to charge another 2 batteries, one in, I think, new condition, looks like I've never flown this, and one, well, also quite a few dents in there. So, yeah, let me move the camera, sorry for the shaking, to my power supply here, magnets right on top of it, and yeah, let's put it a little bit higher. And I hope you can see and read the charger screen. So let's try. So I will connect this battery to the output number 1. So that's the 400 milliamp LiPo. It shows 4.166 volts, which is, yeah, fully charged. It takes a little bit after it's been on the charger at 4.2 volts. This just depends on how much how long the CV part of the CC-CV charging curve is designed. So I could have it sit there a little bit longer, I would closer to 4.2 volts, but it really doesn't make much of a difference. That's what they usually come off from this charger. So what I will do is use a pre-programmed discharge setting, what I have here saved on LiPo 12 amp, and it is configured to discharge with a maximum current of 12 volts, 12 amps. And here is, that's the first important value of that setting. The second is it says discharge voltage. I call it the cutoff voltage, which is currently set to 3.3 volts. And would you please comment in the chat room if you can read those values? I can try to put it a little bit closer as well. There's some reflection. Let's turn it a little bit. So how's that? I can still read it as well. So these are the first two important values, 12 amp and 3.3 volts. That means the charger will try to draw 12 amp maximum out of the battery, and because the voltage will sag when it's doing that, as soon as the voltage hits 3.3 volts, it will reduce the current so that the voltage does not sag below 3.3 volts. So what I expect to see when I start this program is, at first the voltage will be at 4.166 volts, and then the current will be displayed right underneath, will rise up to a maximum of this battery, probably not anymore, to 12 amp, and the voltage will drop at the same time. And if you see the voltage drop to 3.3 volts or below, you will see the current being reduced. So this is a so-called CC-CV discharge curve. That means in the beginning, CC, we keep a constant current, and then when we hit that cutoff voltage of 3.3 volts, we will switch over to CV, current voltage. So in the first part of the curve, we adjust the current, and in the second part of the curve, we indirectly adjust the voltage. So we can't influence the voltage directly, we can only influence the voltage by changing the load, meaning the current. But yeah, that's what it's doing. So yeah, let's just get started. Just one for yeah, a little bit of explanation how this works. So I click on discharge and I say yes. So you see it takes a little bit to start, and then it will slowly ramp up the current. Now it has hit 3.3 volts and it peaked out at around 11 amp and quickly drops below 10. If the battery is fresh, they deliver a little bit more. They don't peak out much above 11, but they stay longer above 10 amps. So you see now it's trying to keep the voltage constant, not 100% successful, so it fluctuates between 3.25 and 3.36, 3.8, 3.4. You see it's still holding the current at 8.5 amp. And it's already quite remarkable for such a little battery. After 1 minute, it's still above 8 amp. Most other batteries in that size would not be able to sustain 8 amp for even 10 seconds. At around 6 amp, that's the third value which I've put, you have configured this on a different screen. At 6 amp, the whole process will stop. So 6 amp is the cut-off current for the CV part of the discharge curve. I've set it to 6 amp because at around 6 amp, the current is so low that I don't expect a quad with 4 8mm motors to fly anymore. So yeah, basically those 6 amps are required to define an endpoint for the realistic capacity measurement. So I leave that process to run through once to show you how I also measure the capacity of the batteries. But yeah, that's rather secondary. It's relatively predictable how much capacity you get out of the pack if you know the material and if you have done a few tests on it. So the better the less the voltage sags in the beginning, the more capacity you usually get out of this as well. And well, it depends on how you set the cut-off current for the CV part. As I said, I've set it to 6 amp just to give me a one reference, and I run all of them down to 6 amps, and then I can roughly see what kind of capacity they have. So that's finished. Slightly warm, I'd say maybe 40 degrees Celsius. And if the battery doesn't get warm, well, it's not good either. Then it means it doesn't perform properly. So we can draw around 400 milliamps out of this 480 milliamp pack at somewhere between 11 and 6 amp with 11 amp peak. It's usually to be expected that most batteries do not yield the full capacity if you drive them hard. But yeah, that's also a definition. I would expect that the capacity on the battery, in this case 400 milliamp, can actually be achieved by pulling 40C out of it. But yeah, that's just a pipe dream.
It's 12 hours.
So yeah, that's just as a reference. So that's kind of a medium pack, already been well tortured. But yeah, this pack delivers around 11 amp peak. So what can we derive from that? So the first thing I always like to do is compare the current with the weight. So, well, I should calibrate the thing first. That is 14.97, so 15 gram and 11 amp. So I want to find out how much amp per gram. So I divide 11 by 15 and I get to 0.73 amp per gram. So that's what I call the punch ratio. How much power does this pack have per weight, which also allows me to compare different battery packs even though they don't weigh the same. And the second value, what you can derive from that, is the C rating. So 11 amp, how do we get to the C rating from that value? We will divide the measured current by the given or by the measured capacity. Well, let's, for simplicity's sake, let's take the stated capacity. So we have 11 amp and we divide that by 0.48 and we get to 22.9, let's say 23, let's be friendly, 23C. So according to my measurements, this, well, I'm going to be fair, slightly used battery pack delivers 23C, and it's stated at 40C. So what you also could do is calculate the bullshit factor. So you could create a relation between the stated C rating and the measured C rating, and from that, you can draw conclusions on the other packs with similar material produced by the same company and marketed by the same marketing department. So, quick look at the chat room. Here's some nice bricks where you put your batteries in. I think that's a good idea. Lighter fluid, power density, energy density. Let's move on to the money shot, I guess, to the graphene batteries. Didn't I have one more? Where is it? Behind here. So let's move on with the little ones I got. That is the, repeat the label of this one here. So these are 750 milliamp graphene batteries. I will connect this up here. Oops, is it not charged? Damn. Let's put it back up on the charger and leave that for later. I'm pretty sure this one is charged. Yep, 4.18 volts. So the larger the pack is, the smaller the same current is in relation, and that's why the charger cuts off later, always in relation to the battery size. So that's why you sometimes see a little bit of difference. So this pack has 0.02 of a volt more, but yeah, that makes very, very little of a difference. So same procedure, I take the 12 amp program, I say discharge, I leave the values the same, let's see what happens. So it gets going, voltage starts dropping, current is rising, 10 amp, 11 and a half, 11.9, 11.12, 12 amp. So it actually hits the roof at 12 amp. So that's the maximum what I've currently set this charger to draw from the pack, and it actually delivers 12 amp. I could have gone a little bit higher, but due to the fact that after a couple of seconds it already starts dropping quite quickly from 12 amp, I still found this to be a representative test of its capacity, because we're testing continuous discharge. So after 1 minute, it's dropped to 10.5 amp, whereas my LiPo pack was already at 8 amp at this stage. So we still haven't hit 10 amp after 1 minute and 20 seconds. So it's definitely more powerful than that 480 milliamp pack. I will let this cycle finish because I'm also interested in the whole in the total capacity, and use that minute of a break to again look at the chat room. Hello my friends, Madman is back. Seru Lin Blue is already a little bit impressed. Yeah, I was also a little bit impressed by that. Look at that, 2 minutes and it's still at 9 amp. And I can tell you the plug and the wiring is getting decently hot. The battery, not so much. Yeah, a little hand warm, maybe 30 degrees Celsius. But yeah, the wires are really at the limit. It's only another minute or so left, so that's why I'm not too concerned that the wiring will melt. And also, yeah, the big part is over. So the couple of seconds where it's pulling 12 amp, that's what really gets the wires heated up. But I already feel that the temperature on the plug is now coming down. 8 amp is not that much for these plugs. So, we're using these red JST plugs, and I'm not sure what they're rated at, but for my use, I rate them at 10 amp, which, yeah, around, you can't run 10 amp continuously for it, but for the time we run them at for like 3 minutes, 10 amp is perfectly fine through them, even though, yeah, they get warm. So you might lose a little bit of efficiency, but plugs were perfectly capable of running 10 amp for extended period of time. Now it's almost down to normal temperatures again, only pulling 7.5 amp now, and the battery is getting quite good warm. I'd say maybe 40 degrees now. So much hotter I would not like, but yeah, it's still okay. So still pulling strong, 7 amp. That would be still good enough to fly around. Not very powerful, but you wouldn't crash an 8mm quad when it still can draw 6 amp. So almost hitting 6 now, and done. 690 milliamps. So that means the capacity is quite accurate. As I said, most batteries don't deliver the stated capacity if you run them at the limit. And the charge current or discharge current, quite impressive at 12 amp. I would say if I would have made an open discharge, meaning setting the current a lot higher than my expected maximum current before it hits 3.3 volts, we might have seen somewhere around 13 amp. So let's be generous and let's assume we would be able to pull 13 amp for this to set it as a max and compare that to its weight. So weight is 20 gram, spot on, 20.04. Can you see that? Probably not. 20 gram. So this is the 750 milliamp. It weighs 20 gram and it pulls 13 amp. So that is 20 divided by 13. No, other way around. 13 divided by 20 gives me 0.65 amp per gram. So to confirm this 13 amp, I'll wait a little bit for this other pack to fully charge and then run it through a similar program with a higher maximum discharge rate, which I'm going to do in a second for these 950 milliamp packs as well. Oh, more mail, I think. Hello? Good, yourself? Awesome, thank you. Thanks. So, complimented me on my, show this off for a sec here. And flies FPV, that's what I heard. He probably doesn't know on, just sees me walking around like a dog and talking to myself with this funny headset. Yeah, so what do I conclude of these values so far? Oh, hang on, we didn't calculate the bullshit factor, right? So, nah, come on. Doesn't matter. It really doesn't matter what's on the label. So, this is 0.65 amp per gram compared to 0.73 amp per gram for these my lipo packs. So my preliminary conclusion of that quick test is this battery delivers more punch than that my lipo pack in absolute terms, but in relation a little bit less. Yet quite impressive. So far this battery had by far the most punch in its weight class compared to any other battery I've seen, but also in relation to its weight. And even though this one here delivers not much, but noticeably more current, it's not enough to offset its weight difference. So that's why I assume, I don't know, but I assume that the, I think 600 milliamp pack, which might be similar in weight to that 480 milliamp MyLipo pack, I assume that it will deliver slightly less than 11 amp peak, just based on the power to weight ratio of that 750 milliamp pack. So before I move on, any questions? Question comes right in. No, Scott, I don't have the 600 milliamp packs. You're saying that you think the 600 milliamp pack is punchier than the 750 milliamp pack based on your experience when actually flying it, and that's exactly what I would have predicted as well, assuming that the 600 milliamp pack performs more like that 480 milliamp pack, like instead of that 750 milliamp pack. I think you get better performance out of a little lighter pack, given the application what we have, because we're already driving the motors to the limit with this pack. So it doesn't help much when we add more power if we add more weight at the same time. So it will only be an improvement if we can deliver the same power with less weight or more power with the same weight. But if we add more weight, we also need to change other things. For example, put bigger motors on there. So that's why, yeah, I'm a bit disappointed that I don't have 600 milliamp packs. They would actually have been a better competitor to this pack. But yeah, also in my brief performance tests, I think adding 5 extra gram for extra potential current draw is just not worth it. So yeah, please, Scott, have a look, see what they weigh. I think the only good application for this pack is larger quads, meaning either a hexacopter with 8mm motors, a octocopter with 7mm motors, or also a geared quad with 8mm motors. That's where I would use this pack. And assuming that this pack performs similar in relation, that's probably what I use on an 8mm octocopter, or on also a geared 8mm quad will have no problem lifting this thing. But then, rightfully so, we should also talk about energy and power density, because you don't need that much power density on an 8mm geared quad. You would probably be better with actually using a lower C rated battery, which has in terms, in return, more capacity per weight. So it's sort of a triangle between power, energy, and weight. You can only push it towards two of them. If you have more power and more energy, you also have more weight. So let's move on. (950 milliamps), and to give that a fair workout, I will slightly change the parameters of the discharge curve. So let's assume I want to use that pack on a octocopter. So I want to have double the discharge rate. I want to be able to draw 24 amps, which should be an easy exercise for this pack because it's rated at 65C at 950 milliamps, so it's almost 65 amps. I think we should be safe by pulling half of this, right? So I go to the same program and no, don't start yet. And I change the discharge current to 24 amp. This will also change the cutoff current, because in the background you got to go way back in the configuration to change this. I'm not going to do it now, but the cutoff current of the CV part is defined in relation to the discharge current. So I set it to 50%. That means at 12 amp it bottoms out at 6 amp, and at 24 amp it will bottom out at 12 amp. So that's probably not ideal because it will, I assume this pack will not deliver anywhere near 24 amp, so it will probably hit the 12 amp relatively quickly. But yeah, that's not too bad because otherwise, if it actually would deliver that for a longer period of time, the wires would melt. So I just run it at that program and see what I get. The problem of doing it this way is I only literally have one shot, at least during that live event, because once I discharge it and then I figure out I have to do it differently in some way, I need to charge it up in the meantime again. Oh, by the way, look at the voltage. It's slightly above 4.2 volts. That's no good. Gotta check the charger a little bit more frequently. Although 0.01 volts over 4.2 isn't that much of a concern, but yeah, still not nice. Yeah, in case I mess this up in some way or another, I have another pack of those to give another try. And also there's this charge, this pack here almost, no, still needs a little bit. So yeah, let's give it a go. 24 amps. Go. So, it's getting going. Voltage starts dropping. 3 amp, 5 amp, 6 amp, 10 amp, 12, 14, 15, 16. 16, and very briefly hit 16 amp, and then continues to drop. 13 amp after 30 seconds. And yep, the cabling gets very toasty. But yeah, it's over in a second. 12 amp, and come on, done. So 16 amp, and it delivers 160 milliamps. So you can clearly see the 12 amp lower cutoff current is not really a practical value for this battery, but what it gave us is the very maximum current you can safely, I would say, draw out of this thing, which is 16 amp. So that is 16 C roughly, because we're almost at 1 amp. So instead of 130 C peak, we have 16 C peak. Womp, womp, womp. So let's try the other pack and change the parameters based on that little experiment. So I will go down and, no, not run yet, tab and change it to 16 amp. So that will set the cutoff current to 8 amps. I think that's a fair value. So here we go again. Voltage is dropping, current is rising, 1 amp, 2 amp, 5 amp, 10 amp, 14. Oh, this one didn't even hit 15. So yeah, I think 16 amp maximum is a good value for this pack. So yeah, 16 to 15 CE peak. And yeah, continuous, really depends on how do you define continuous. But I would say continuous means at least a minute. So continuous seems to be around 11 amp if you consider 1 minute. But if you would actually consider the whole discharge curve, it will be less. But yeah, for the sake of this test, let's say 15 amp. I can tell you, stuff starts smelling already. Wow, this plug is really hot. I'd say maybe like 60 degrees Celsius. A little bit more and it will start to melt. Which is, yeah, a little bit of a risk in terms of, the wires can actually melt together and then you can't unplug it anymore. But yeah, it's not much of a problem. If this starts burning, I'll just yank out the plugs directly on the charger and use the wires to throw it out of the window. So yeah, that seems to be a much more usable current space for this battery to run in. So after 2 minutes, it still delivers more than 9 amp. And, oops, pressed some buttons. Sorry, didn't do anything. And it's not getting very warm. I'd say this battery is probably around 25 degrees Celsius. And the plug, cooled down a little bit, but not too much. So we're at 9 amps and 450 milliamps. So set it to 16. So at 8 amps it will cut off, which is not too far away. So let me measure the weight in the meantime. So 15 amp and, come on, 15 amp and what, 27? Really? 26.6. Okay, let's say 26. 26 gram. So we divide 15 by 26 and we get to 0.58, 0.58 amp per gram. So, and it only comes to 616 milliamps. So, me. Okay, done. Oh no, hang on, let me leave the camera here for another sec and pull that second battery through. This is another one of the 750 milliamp. Oh, let's use a different plug. This one's still hot. Just to confirm the values I took earlier. So now I'm going to change it back to 12 amp. Start, go. So yeah, it was only at 4.13 volts. There, let's see. 3, 5, 6, 7, 9, 11, 11.9. Yep, hits 12 amp as well. And then very quickly leaves that 12 amp as well. So I assume the 13 amp, what I put in here, are probably quite optimistic. Yeah, but it certainly hits 12 amp, which is quite good performance compared to many other packs in that weight. The big question on these packs will be, how long, how often can you do that? So yeah, similar results. I think you might have seen enough of that. Back on the solder station, the camera goes. Let me see. I go back in the chat room. The geared dropped some jaws today, says Mr. Rebel. I assume you're referring to your geared 8mm quad. Yeah, these things fly very nice. Going further through the chat room. Talking about PID and rates. Yes, I don't know. I was talking a little bit about the charger in the beginning, but not too much. It's indeed a very nice charger, and I specifically bought it for this purpose, and that is discharging. It's quite expensive at that, but it's the only charger I found which delivers a proper discharge rates of I think up to 40 or even 80 amps, and some further fine-tuning of the curve, because there's no point in having a charger which delivers a high discharge rate if you can't configure the lower cutoff voltage and the cutoff current, because if you can't configure that cutoff voltage, well, I didn't talk too much about it, why I've chosen 3.3 volts, might do this at this stage. If you can't choose that that voltage, if it's too high, you will not be able to test your batteries according to the application you want to put them in. And if it's too low, you might just burn up the batteries while you're doing that. So I thought quite a while about what voltage should I use to limit my tests. You know, there's various opinions on that. Let me outline the two extreme opinions on that. One is saying the nominal voltage of these packs is 3.7 volts. So you should only draw as much out of them as long as the pack sustains 3.7 volts. And the other extreme opinion on this topic is you can draw as much current as long as the voltage stays above 3.0 volts. So again, pulse 600 milliamp. So this pack pulls roughly the same capacity as this pack running on 6 amp cutoff running on 8 amp cutoff. So I'm not sure if they use the same material. The 750 milliamp pack seems to be way better to me than the 950 milliamp pack, taking their difference in weight into account. So talking further about cutoff voltage, somewhere between 3.7 and 3.0 should be the right cutoff voltage for these tests. Or in general, that's how far you want to draw down your batteries in voltage while you're using them. So if you set it to 3.7 volts, there's just not anywhere near enough current coming out of these things to fly properly, so no point in that. And if you run them down to 3.0 volts during a discharge, at first things what you have witnessed in the beginning of the video happen a lot more often, and also when actually using them on the target equipment, you get a lot of problems. At first, the motors don't perform that well anymore on 3 volts. The difference in speed is significant between 3.0 and 3.3 volts. And the electronics usually have problems. So receivers, voltage regulators, flight controllers all tend to have issues below, some below 3.5, some below 3.3 volts. So that's why I've settled for my tests on 3.3 volts. If I have some reason to believe that a different value makes more sense, I'll change that. But for now, I seem to sail quite well with 3.3 volts. So let's have a look further in the chat room. I see some impressive charging setups here from Denovic. Scrolling through, I don't read everything right now, so please, if you want to talk to me specifically in the chat room, please put @Dr. Ben in your chat message and it will make pling and give me an orange marker in the side so I know that you're talking to me. So yeah, to conclude my little battery test, in terms of power density, a beaten up my LiPo pack still beats those 2 graphene batteries. And in relation to their weight, my LiPo pack delivers 0.73 amp, 730 milliamp of current per gram while keeping the voltage above 3.3 volts. The 750 milliamp graphene battery delivers 0.65 amp, 650 milliamp per gram while keeping the voltage above 3.3 volts. And the 950 milliamp pack delivers 580 milliamp per gram above 3.3 volts. So if we can extrapolate this trend towards the 600 milliamp pack, if we get more than 650 milliamp per gram, it seems very possible to me that the 600 milliamp pack graphene will be a good competitor to the 480 milliamp MyLipo pack, assuming that they are similar in weight. So that's my conclusion on these packs. any more questions, guys. Otherwise, I have already made fair use of your time. You're already well into the second hour, so I'm gonna call this a day in a few minutes after I unpacked this nice package here from Ungsu Chungwang Garments. Garments? Garments is clothing, right? No, can't be. Looks like a Banggood thing shipped quickly. So, if you order something on Banggood and make them ship it quicker, they just take their usual garbage bags, what they pack their stuff in, and stuff it into some extra delivery courier bag, in this case from Dipex. I think I already know what this is. Let's see. Oops. Stuff's falling out. Yeah, so a receiver. Another receiver. Guess what? Another receiver. And surprise, another receiver. And finally, another receiver. So, as you might have guessed, I'm planning a FPV party. So, a few other parts, as I said, also came in the last week. Oh, not this one here. I only show it to you very quickly, so I don't have people breaking in my house and stealing my valuable possessions. Just very quickly. Can you see it? Can you see it? Was it quick enough? So yeah, lots of antennas. I plan to build up another one of my spectator ground stations and provide that to the folks of the D1 National Drone Spectacle to record four-way downstream footage, Dr. Ben style. So yeah, that will be happening on the 2nd and 3rd of April. So I'm preparing my stuff to drive the 1,500 kilometers down the coast to lovely Ballarat. I've never been there. I didn't have many people sign up yet for the trip, but I will have 2 seats for those of you who want to come along. So Ash, decide yourself, and anyone else who is somewhere in Australia on the way. So I would say somewhere in Sydney or Central Coast, Newcastle, Wollongong, somewhere in the area. Send me a message and we'll pick you up along the way. So the plan is to, at first on the 29th, drive to the Google head office in Sydney to participate in the walk-in, fly-out event, which is kind of funny because usually we fly in and then walk out. But yeah, this time it's supposed to be an enablement seminar with live building where you can learn how to build a FPV quadcopter. It's, as far as I know, free for Google employees, and everyone else who wants to spectate I think the tickets cost $27.50, and that is on the 29th of March in the Google Australia head office in Pyrmont at 6 o'clock at night. So yeah, that will be our first stop, and then we find a place nearby to sleep, maybe a little bit down the motorway in Mittagong somewhere, and then continue on the 30th to drive down the coast. We have 3 days to arrive in Ballarat. If we make it in 2, we can also participate a little bit in the practice runs on Friday. I've read on Facebook that they will open the track a day earlier. So yeah, if we drive a little bit more every day, we might be able to arrive there by Friday lunchtime. Yeah, I heard a quadcopter is something like a drone. Actually, I was thinking about taking T-shirts to the drone festival, saying it's not a drone. I just don't think it's a drone. It's such a ridiculous name, you know. At first we use it for, well, hang on, I show you what I think what a drone is. I wanted to do this for a long time, was thinking about it, say, I'll at some stage I will make a video and I show everyone what I think what a drone is. And it's way older even than, well, I think the first term is probably, it's a male bee in the first part. And then we came to the stupid idea of naming something completely irrelevant also drone. So I'm not sure how much of that drone will be picked up by the microphone, but this is a drone. The bass vibration of some sound, particular pronounced in a didgeridoo, that subtone, in this case, a low-key E, that is a drone. And yes, I agree, male bees are also drones. But quadcopters are not freaking drones. Anyway, I think we have to accept common lingo, and instead of making up all sorts of explanations, if someone asks me if it's a drone, I said just say yes. So far to drones. Yes, Adam, you definitely touched a nerve. I don't like to talk about this because most people just don't understand and think they're just, why are you so upset about a word? We use language to describe certain things, and why do we make such stupid choices? But yeah, anyway. Yes, I mean the noise. Yeah, exactly. And we also, along the way, called military drones, military weapons drones. So we have bees, noise, and military attack airplanes, all already called drones, which is already ridiculous enough. And then we also call quadcopter drones. Yeah, anyway. That's it. I hope we do not accumulate more words down the track, which we call drone. Yeah, multi-rotors. They're also called multi-rotors. That's right. I was actually, when I was thinking about that, my LiPo T-shirt, what I have, on the back it says, "My heli, my passion." So I was thinking, is it, still appropriate? And I was looking at the term helicopter, and it applies to a multi-rotor. So you can perfectly, with staying in the definition, call this a helicopter. There's no point in at least most definitions, what you read, that a helicopter can only have one rotor. In fact, most helicopters have two or more. Um, and it doesn't state that one of these rotors need to be upright. So according to my understanding, this perfectly qualifies as helicopter. But yeah, I also understand that people needed a simple word for it. I would have just preferred to use one which not already has a gazillion of other completely unrelated meanings. So leave it to the English language. Yeah, I'm sorry. As you might know, English is not my first language. So who am I to complain? On the other hand, we have sort of agreed to, amongst many other nations, to use English as our common way of communicating across country and language realm borders. So I would appreciate if everyone makes an attempt to actually use different words for different things. I'm not asking for more. Funny picture of Denovich's drone garden. Google self-driving cars should be drones, not the FPV shark. Exactly right. So yeah, so far to that. The other package, I've already seen what's in there. It's not spectacular. I would unpack it if it would be interesting, but it's just plastic bottles. Talking about plastic bottles, I'm not drinking enough. 6 liters of water per day. So, any more questions to the batteries? Any more suggestions what I should do to make my measurements more accurate, more applicable, or maybe even safer? Although, yeah, it doesn't really matter. Um, it is dangerous to have these batteries explode, certainly, as long as it's not supervised. One of these batteries explode, yeah, it burns a little bit, but it doesn't create too much heat and flames, and it's very manageable as long as you are close enough to the thing to yank it out of the charger and chuck it out of the window. So the main danger is posed by these batteries, A, during charging, and B, while being stored, charged. So it does not only um, create damage to the battery as in reducing its capacity if you are and reducing its discharge capabilities if you let it sit charged, but it will also um, increase its probability of having a wild problem. Plus, it will significantly change the way it unloads. So this battery, what you've seen, let me get it back again to continue making this point, because yeah, if you're not watching your batteries while you charge them, it can kill way more of your possessions than just this little battery. So as you've seen, this pack has produced a lot of smoke, not so much flames, but a lot of smoke, and if it would have been sitting next to other flammable stuff, for example, next to other batteries, this could have been quite dangerous and created a chain reaction and blow up my whole place here. So I only charge batteries when I'm here. So and I only keep the batteries charged for the shortest amount of time I can. So before I start flying, I then put the batteries on charge. That's why I have so many of these chargers. So one of these chargers gives you 4 outputs, and you can charge one of these packs in, depending on how aggressive you are, between 30 and 60 minutes. So yeah, this just means you need to plan a little bit in advance. If you have 2 of these chargers, you can charge 8 packs in 1 hour. So before you start flying, 1 hour planning in advance, put 8 of these packs on charge, and while you fly, charge another 8. So that gives you continuous flying with 8 batteries and 2 chargers. The difficulty obviously is if you have larger packs. So I only can charge 2 of those at the same time, but I like to take more of them on a field trip to be able to charge my smaller batteries of this one. But in order to reduce my risk and also increase my capacity, I've actually followed one hint that I got in the last live stream. It's good, I just outline my problems here and people come up with solutions. The only thing I still need to do is buy the stuff. I hope this doesn't now ruin my video feed, because I'm actually running my ground station off this little battery pack here. Let's see, I hope it all stays intact. So this is a Goal Zero Yeti 150. It's a 14,000 milliamp or 14 amp hour 12 volt pack, which someone suggested in the last stream I should use to power my stuff on the field trip and charge it with a solar panel. I decided against the solar panel because it will take 18 hours to charge this thing with a reasonable sized, already quite large solar panel, while it will only take 8 hours to charge it in the car. So, and because we plan to drive quite a bit anyway, I will put this thing on the 12 volt output while we drive, and then we will have enough juice to charge batteries while we camp. So one of these roughly gives me 32 charges of a 400 milliamp pack. So this is around a third of the capacity of the other pack. So it gives me around 100 charges of these little packs, which should be enough for an afternoon, right? Yeah, so I plan to fly with a few other people, so everyone 10 packs maybe or so for an afternoon, 30 packs. That still leaves 2/3 of the capacity in there, which we can use to charge transmitter packs, goggles, and also to power the ground station. So the ground station, including video encoder, video recorder, and 4 receivers, pulls around 1.8 amp. So with no other loads, you could run this for almost 8 hours. So I think this little battery pack there, which I think weighs around 4 or 5 kilogram,
13 hours,
should be enough to entertain us, 3 or 4 of us flying FPV with micros for a whole afternoon. That's the problem when you're thinking about it. If you want to fly larger copters, where do you charge them? Because yeah, charging them from a 12-volt outlet in the car, not always safe or fast. Pick one, fast or safe. Um, and yeah, lugging around larger batteries to be able to charge larger packs gets very, very expensive quickly. And yeah, the only alternative is to be dependent on the grid or on um, a power generator. But yeah, I think running this 14 amp hour pack, which is apparently made to actually be discharged over that capacity as compared to these jump starters what I tried. I hope that this will be at first a good entertainment on the way, and second, when we arrive at the drone spectacle, that it will be enough to power my ground station independent from any power points which could have a problem. People can trip um, over the wire, or you get interference from the power supply. So that's why I will also use this to power my ground station. The days are probably going to last, according to the schedule I've seen, 4 to 6 hours of flying. So I hope this thing will power it all the way, and I connect a 100 gigabyte hard drive to it to record, I hope, in 1080p. Let's see. Okay, about to call it a day. Any more questions? I said if you still have any questions about these graphene batteries or about my discharging setup, I'm happy to answer this. But if you want to continue talking about hops and weed in the chat room, you are most welcome to do that as well. JG says he has a 100 amp hour gel cell and hook it up with a dual charge regulator. Put plugs in the back for multiple chargers to connect. That sounds good. 100 amp hour gel cell. And Danovich says he's using a Sky RC 4-port with a 2.2 LiPo, charged 8 batteries. Yeah, you can just use a regular charger as well and use these parallel plugs to do the same thing. So half of that, 2.2 amp hours, should give you around 16 maybe charges of a roughly 500 milliamp 1S pack. How do you calculate that? At first you have 3 cells, so every milliamp in that pack should result in 3 milliamps in that pack, right? Because it's 3 cells here, only 1 here. So you can multiply this by 3, gives you 12,000, and then divide that by 480. 12,000 divided by 480 gives you 25. So I said 36, and that's because in most cases you will not discharge this pack completely because we're drawing more amp than maybe the manufacturer thought we would, but we're not getting 480 milliamps out of this, but only around 400. So there you go, 30 maybe. So, thanks Cerulean Blue for pointing out that there's still the YouTube chat room. I completely ignored that in this case. Nathan Rubio, yes, I'm from the future. It's 13 o'clock here on the today not so sunny east coast of Australia. It got so cold today that I'm wearing socks. So Does he read the YouTube chat? No, he usually doesn't. He has put a link to a Discord chat into the video description, but I now read the chat. I'm sorry that I didn't make this more clear. So what was the question? Will you release a kit of some kind? You mean complete quadcopter kit? Drone kit? The only thing what's still missing is flight controllers. So as soon as we have solved the flight controller problem, the alien brain shortage, I will do all I can to offer complete kits containing everything you need to build a FPV microquad. You know, we started with motors, we continued with frames, we moved on to propellers and batteries, and my next coup will be FPV cameras, and well, you know, I tried hard in selling flight controllers. Some of you might remember um, the fun we had with selling and chasing alien flight controllers on my website. I hope there will be a sequence to that chapter. You, JG is already wearing slippers last night. Yeah, it's getting frigging cold in Australia. Yes, looks like the cast is over. Did I click some wrong button already? Is it already over? Should still be on. Walking Dead. All right, no more questions. Thanks a lot for watching, guys. I will see you all later. Wrong. Didn't get it again. Let's try again. I will see you all again later.